Alrighty, today, folks. Today we are going to talk about the scientific method. Alrighty, first things first, I want you to go ahead and jump over to our Schoology page and just go ahead and take quick quiz 1.2. This is going to be your attendance for today. It's over lab safety. Just a couple quick reminders. It is worth 5 formative points. You get as many attempts as you want, and the first attempt of this quick quiz is on your own without notes or help from anybody else. After that, you can use your notes. You can ask other people for help. You can take it as many times as you want. You'll keep your highest score. It's meant to be a study tool. So go ahead and pause this video and then go take that quick quiz. Alrighty, folks, now that our quick quiz is done, let's go ahead and set up our notes. So you can go ahead and pause the video to do so, but you know how to set up the heading. Our topic for today is scientific method, and our essential question that we are going to be able to answer by the end of today is how do you apply the scientific method? And just a quick note, we will be using this same notes page tomorrow for the notes then. All right. Your learning target for today is I can explain and apply the steps of the scientific method. All right, folks, I want to go ahead and have you pause this video that you are watching of me lecturing, and I want you to go over to the Nearpod and I want you to play this video. And what this is it is the science behind knuckle cracking. It's a very cool video, and I think that you will learn some neat things from watching it. So go ahead and pause this, watch that video, and as soon as you're done, come on back to the lecture. All righty. So now that we've watched that, let's go ahead and talk about the scientific method, and we'll kind of jump back to that knuckle cracking video and use it to kind of help clarify a couple of these steps. So I want you to go ahead and turn to this handout in your packet, make a note in your notes that you're turning to the scientific method handout, and what you're going to see here is the 7 steps of the scientific method laid out. Now, number one, it is very, very important to know that I'm going to expect you to know the 7 steps of the scientific method in order, number 1 through 7. So make sure that you work on memorizing the order. However, I also expect you to know what the different steps of the scientific method are and kind of how to apply them. So let's go through each of these boxes and talk about that. So first up is our purpose. Purpose is asking a question. So what you are doing in the scientific method is you are asking a question that you are trying to answer. So let's go back and think about that knuckle cracking video that we watched. In that video, there was the gentleman who cracked his knuckles for, I believe it was 60 years on one hand and did not crack them at all on the other hand. The question that he was trying to answer was, does cracking your knuckles give you arthritis? So that was the question that he was trying to answer. Next, research. Once you have determined what it is that you are going to be experimenting with, or the question that you're trying to answer, you want to perform background research. You want to learn a little bit. Number one, maybe you want to find out if anyone's ever run an experiment similar to yours so that you can get some information about that. Maybe there's something that's really important, or there's some surrounding science that you need to know about in order to best perform your experiment. So, for example, let's say that you were performing a knuckle cracking experiment like that guy did. Maybe, like in the video that you watched, it would be good to understand what is it that happens when your knuckle crack or you crack your knuckles. So he could have done research and found out what exactly is knuckle cracking to better understand and move us on to our next step, which is hypothesis. What do you think will happen and why? And so you need to, once you have said what your question is, you need to propose an answer to your question and why you think that is the answer. Now, you have to have both parts, what and why. So going back to our knuckle cracking example, after that gentleman had done research, maybe his hypothesis was along the lines of, I do not think that cracking your knuckles will cause arthritis in your hands because cracking your knuckles is just releasing air from the fluid in your knuckles. And that's what he thinks will happen and why. So that is a hypothesis, is an educated guess with an explanation. Next is your experiment. You want to test your hypothesis. So this is going to be materials, procedure, that kind of part of the scientific method. And so for the knuckle cracking, that was the actual process where he went through and cracked his knuckles. Next is analyze. This is analyzing data, both quantitative and qualitative. And when I say you are analyzing your data, you are looking for patterns in your data. What do you notice when you look at your data? You're going to end up with numbers or explanations or observations, and you are looking for patterns in those things. So that is your analysis. And those are going to lead you to your conclusion. You form a conclusion. What is the answer to your question? So, for example, when the gentleman did the knuckle cracking, the data he collected was that he did not have arthritis in either hand. And so that's the data, and therefore he is able to form the conclusion that cracking your knuckles does not cause arthritis. And finally, communicate. Share your results. This could be writing a lab report. This could be publishing a paper. It could be making a poster and presenting it at a science fair. It could be writing a blog, making a video. There are a lot of different ways that you can communicate what you found, but the important part of science is that you share your information with other people, not only so they know what you did, but then they can run your experiment and they can see if they get the same results and draw the same conclusions that you do. And that's what's called peer review, and that's what makes science so powerful. So this is what your scientific method handout should look like. Make sure you have all of that filled out. All right, I want you to go ahead and pause this video and see how quickly you can list the 7 steps of the scientific method. Time yourself and see how quickly you can do it and how many you got right. All right, how did you do? How many did you get right and how much time did it take you? Go ahead and enter that information here onto this slide and we will see how everybody did. All right, so now that we're done with that handout, go ahead and flip back to your Cornell notes and let's go ahead and just do a couple of quick things on a few of the steps of the scientific method. So first, let's talk about purpose. A little more in depth. A purpose is a question that an experiment attempts to answer through the scientific method. So a big part about the scientific method is that you are trying to answer a question about the universe. You are trying to discover more about how our universe works, how anything, how the world operates. You are not trying to make something. That's a different process that we'll talk about later. You are trying to learn something about the world around you. And your hypothesis is going to be your proposed explanation for your purpose. What do you think is the answer to your question, and why do you think that? A quick note, both of these words are in uppercase letters because they are vocabulary words. So anytime you see all uppercase letters or words, those are vocab and they are important. All right, I want you to go ahead and tell me, what is a question that the previous slide answers? Pause the video and go ahead and write a question in the left-hand column of your notes. All right, next up, variables. A variable is an aspect of an experiment that can be changed. This is anything that can be changed potentially in an experiment. So let's think about our knuckle cracking experiment for 60 years from this previous video. So what are some things that could change in this experiment? Well, for example, the gentleman popped knuckles on one hand, but not another. So that's something. He popped on one and not another. That's something that could change. The amount of arthritis that was in his hands at the end, that was something that could change. You could also look at things like, when did he pop his knuckles during the day? How often did he pop his knuckles? One other thing is that he kept it very consistent, that he only popped knuckles on one hand and not the other. That is something that could change, but he did not change. So, what is a question that the previous slide answers? Pause the video and fill that out. All right, so we have 3 types of variables that we are going to focus on. We have manipulated and responding first. A manipulated variable, vocab word, is the aspect of an experiment that is changed, manipulated. There should only ever be one manipulated variable. You are isolating that manipulated variable to determine if it causes something to happen. So, in our knuckle popping experiment, the manipulated variable would be the fact that he popped knuckles on his one hand, but not the other. So that is your manipulated variable. If you are a math person, you might be familiar with this, y equals mx plus b. That is slope-intercept form of a line. So In algebra, x variable, or the x, that is going to be your manipulated variable. You can plug anything you want in for x, and that is the same thing for a manipulated variable. In science, though, we want to make sure that you only ever have one manipulated variable, just like you in math only have the one x. You can consolidate it, obviously, but one manipulated variable. Responding variable, this is an aspect of an experiment that is observed in order to collect data. There can be multiple. So to our algebra example, this would be y. You plug in your manipulated variable x, it can be anything you want, but you solve for y. So in our knuckle cracking experiment, the thing that is the responding variable, what is being measured, that is the amount of arthritis in the gentleman's hands. And so that is something he measured at the end of the experiment. However, that he could also measure a bunch of other things. He could maybe measure what were the size of his fingers and hands. Did that change over time? That would be a responding variable. Maybe he measures the length of his fingers. Did popping his knuckles change the length of his fingers? He could also measure that. He can measure as many things as he wants, as long as he only has the one manipulated variable, which was popping knuckles on one hand, but not the other. Finally, we have a controlled variable, and in a lot of ways, this is one of the most important parts of our experiment. A controlled variable is an aspect of an experiment that is not changed. Controlled variables are important so that the manipulated variable is the only thing that affects the responding variable. So, knuckle cracking experiment, back to that. A couple of controlled variables was, number one, he may have changed or had one hand that he popped knuckles on and one that he didn't, but keeping those hands consistent. So if he popped the knuckles on his right hand but not his left, that would be a controlled variable as long as he always only popped the knuckles on his right hand and never popped the knuckles on his left. That is a controlled variable. Maybe he did something along the lines of he popped his knuckles 3 times a day, every day. That would be a controlled variable. Maybe he popped his knuckles at the same time every day. That would be a controlled variable. Anything that you keep the same is going to be important as a controlled variable, and having as many controlled variables as possible makes your data better and better and better. What is a question that the previous 2 slides answer? Pause the video and fill that out. All right, folks, that's it for notes. Let's go ahead and take a quiz to see what types of questions will be on tomorrow's quick quiz. Pause the lecture video, fill out the quiz, and then come back for the answers. All right, which are a part of the scientific method? Select all that apply. That would be purpose, research, and conclusion. A problem is actually something that we use the engineering design cycle to solve, as opposed to a purpose, which is a question. We'll talk about that later. A variable that the researcher changes is the manipulated variable. You plant a rose, violet, and daisy to see which flower grows the fastest. What is or are the responding variables? So what is it that you are measuring? And you are measuring how fast the flowers grow. You give 3 samples of grass, water, milk, and root beer to see which causes the grass to grow tallest. Which is/are the manipulated variable. So this is the thing that you are changing with each sample of grass. And in that case, what you are changing is the liquid. So water, milk, and root beer are your manipulated variables. Who can run a 10 meters course the fastest? A dog, a cat, or a hamster? What is or are the controlled variables? And that would be all of them using the same course. That is something that you are keeping the same throughout the entire experiment. So if you answered those quiz questions that way, you should have gotten 5 out of 5. Alrighty. So if you have any questions about what we talked about today, need clarification or anything along those lines, go ahead and post in our Schoology discussion about questions. All right, go ahead and self-assess on a scale of 1 to 5. How well do you understand the scientific method, variables, and data? All righty, folks. Now that we are done with our notes on the scientific method for today, we are going to begin our first lab of the year, and this is our paper airplane lab. You will be performing this lab at home, and you'll be performing and recording all the steps of the scientific method. Don't worry, I'm going to walk you through all of it. Instructions for the lab are in the next video, so when you're done with this video, done with notes, and are ready to move on, you can head over and watch that video to find out how to do the lab. You are allowed to work with a partner, but you need to do so digitally, okay? So feel free to partner up with anyone from Mr. Roser's science class. They do need to be someone from my class, but you may do partner work. You just need to make sure that you are observing social distance, and so really doing this digitally would be the best way. This lab is due by 11:59 p.m. on Friday, September 18th, and I'll have more details in the next video. Have a good day, folks.